it created 2 files on the desktop. They were very basic. Oh, so let's go back to the machine. Let's see here. Yeah, T-minus 3 minutes. Oh, I turned the TTS off too. So let's see. So I realized I was like I should have raided, right? I should have maybe given up on getting some more done today. So start the TTS.
Connected to channel 6 of 42.
So we'll see. We'll see here. Let's just minimize these again. This is a bit slow, but this is what the file looked like. Byte array 1, and apparently this is just 256 characters, meaning it's just 00 to FF in there.
FixerBot says T-minus 2 minutes.
And then we have the role. My god, I'm trying to scroll. And then we have the one that we cut from into the Python script that we had here. So it just uses this to create shards that wave, including all characters. I'm a bit curious what they'll do next, because null is in there. Right. So here they're removing null. As you can see, this time it said excluding. Okay. So I jumped ahead, eliminating bad characters. Now that we have identified the first bad character, we should use byte array again. No, I hopped too much.
Stream
more.
About to start. 1 minute left.
Oh gosh. Yeah, so I'm a bit tired of repetition here. So I guess we'll start it. And we'll look at the memory. And exactly this part, I think it's easier to do in a command one. Shh. Come on, machine. I did click tab. There. So, right, let's do this. So, it is paused. I'm thinking we'll just restart it. It is connected, attached. We have the file, so we will select to encode, and we will do, what was the file name? I guess it's chars, right? So first a pattern, then we control the length was correct, and then chars. So I think this is slow motion. I'm sorry. And we got in 42 here. Exception, access violation. Yeah, that's a bit odd. Let's actually look at it again. So I'm restarting this. I'm going to go here and going to see what on earth we did last. So byte array, we got byte array and we used it. I'm trying to tab and it's slow. And this one, bad cars, it creates shards.wave. That's the one I used. And it uses bees for EIP. Okay, that's good. Because I was like, what? So we want it to crash that way. Yeah, so I see a good thing with this is that when I did it on the bit before, it does not crash, so I have to like set a breakpoint to do it. So I guess that is good, but we still have to find it in memory. I guess they will tell us, right? Let's actually read the text instead of just doing it. Open Char's wave. Once we do, we can start comparing our input in memory and seeing whether any characters are missing. To do so, we can check the stack pane at the bottom right. That's where I was looking. We should be aligned exactly at the beginning of the input. Okay, so did I scroll this? So this is selected. We can now manually go through the stack line by line. Let's see. I just want to see what you see. And ensure that all hex values are present. From 00 to FF. As this may take a while, we would entirely rely on our eyes. We can miss character 2. We will once again use ERC to make the conversion for us. So yeah, this is the thing then. So first copy the address of ESP. So it doesn't do it automatically. Since this is, I mean, we couldn't type ESP in here. We probably can, right? Since this is where our input is located, we can do this by right-clicking on it and selecting copy value, or by clicking Ctrl+C. This is so annoying. So, so let's click ESP. Let's do, oh gosh, copy value. I'm sorry. Ah, my nose. I thought that was a good idea. Use ERC to look at the stack here and see if we can find any bad character, which this is an odd way to do it for me. It's new.
What are you reversing?
This is this room. Let's actually hop over there. So sometimes my phone that I control stream with says I can't charge and then doesn't work, so no, there, so, no, it's this room or module, I guess it's called.
Is this or enabled?
This is a Windows 10 machine. I'm assuming it's not, right? But I'm guessing that they'll talk about that later, and maybe we will learn more things about it too. But I've done a lot on Linux before. But this one uses modern tools and modern stuff, and it's not like a VM that has Windows XP. It's Windows 10, and yeah, I'm assuming it's disabled because we'll see. Anyway, we're as we're in the program live, attaching to it. If there's a new address, you know, yeah. So I have to go get the pancakes. I'll be. So I'm a bit tempted to keep streaming and not go train, but I think my body will be glad if I go train, right? So let's see. So let's copy ESP, and we have it right here. So also I saw. So what is the goal? So this is not a challenge, it's a learning, because it's an academy, right? So this is the second time I look at one of these, and the other one was Linux. So I don't have a lot of experience of HTTP Academy, but I think the buffer overflow stuff is much more modern than other sites like TryHackMe, which is nice. Yeah, so we'll see. It does use a Python script for something that's very easy to type and really don't need a script, and it's using the ERC for something that we could kind of easily do ourselves, but I want to learn all the ways they do it. So ERC is a plugin to this x64 DBG that is an open source tool, so we are using the x32 DBG. So let's just quickly look. Now I'm curious.
Yeah, the stack is executable if you can overwrite the return address to go back to your shellcode.
Yeah, exactly. So we're going through this to learn all the new tools and the Windows specific stuff. DBG. And I want to find the GitHub and see when it was updated last. So I didn't click, it's just slow. So last update 2 weeks ago. So this is not like some kind of old thing that's not updated anymore, but it's also not new, 9 years ago here. So I mean, that means that it's like we should probably star it along with 44,400 other people, right? Seems like a nice thing. And there's a dark mode. That's like a good thing. If something doesn't have a dark mode, then it's old, right? And I am running streamer bot. It doesn't have to be old apparently either. Anyway, let's continue. So we want to test this ERC. So did I copy it? If I click, I think I've copied it twice now. Let's go to the log, because this is where we have the commands, and it didn't say anywhere. So ERC, and I have American keyboard, not Swedish, that I would prefer to have because that's what my keyboard is. So byte array. No, that's the old one. What? Did I like hop down? Yeah, I scrolled up before. So instead of looking at something you can't see, I scrolled up to check what name it had, right? Sorry. So let's see. ERC byte array. Bytes. No, but why would I copy that then? This command here, this is what we want. ERC compare. Let's actually be lazy. It's okay to be lazy sometimes, right? And meaning I overwrote my previous copy, so now we'll see the address. 14 F9. No, it's not the same, so let's copy this. And we're on Windows, we can just... Oh, it's so laggy. So selecting text and you see how it jumps ahead with the selection. So now we got this output. Comparing memory regions starting at 2 bytes in the file. I guess this is good. So memory. So I don't understand how this will work later though. So there's no matches at all, right? So let's see if this is the result they had. No, they had zeros. So I thought this is like a bit funny. As we can see, this places each byte from both locations next to each other in order to quickly split. So we still need to do the comparison ourselves. Oh yeah, so no, this is not for me. So it doesn't even do it automatically. It just puts them next to each other. Nah, we can do this better ourselves. So first of all, I'm going to look at the memory because I was like, is this really the right spot? So how do I unfreeze this thing? How do I get back to the ERC? I want the text that was there before, you know? I'll just redo it. Okay, we'll redo it. We'll restart it. We will run with our character starting with null. So it will freeze on the first one. And since these are after our EIP on the stack, it should start here. So now I know that this is the right one because I can see this, I can see this, I can see EIP here. And so one, or to remember it easily, I'll say 14 F9 74. Or it did. Okay. So it's not the same address now. And I guess we will run the command again. Actually, now we have the same number they have, which seems better. So now we can actually just paste this command and run it, and we do see but it's still null, the first one. So there, I don't think this is necessary because you can just quickly check there are no nulls. So let's see, I just got a message. I'll just reply. Just sending a message, okay? Meeting time. So, yeah, so it's easy to check that also that they are lined up, you know, the 8s, for example, and check that there are no nulls. That's usually, you know, you can see F0, 1, 2. You don't need to compare to anything to see this. And it doesn't compare automatically. I thought it would compare automatically. So let's see what it says now. So I'm a bit curious about this. Will compare? No, it won't. It will make us compare it by dividing both of our input in ASP and all characters that we generated earlier in the file. As we can see, this places each byte from both locations next to each other to quickly spot an issue. The output we seek is where all bytes from both locations are the same, with no differences whatsoever. However, we say that after the first character, no, I actually got all the same. So we're still not getting the same thing as they do. So they just had to know. For me, it's all the same. Isn't this wonderful? It's their machine we're on. We're not on ours or anything, you know? Yeah. Let's actually look at it manually. So let's hop back here. And I can see here 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B. So these are very short lines, so looking at it manually in this might be harder, actually. But I'm assuming I can change the format of this. So I don't want it binary. So I know that this is a right, so we have here too. I haven't looked at the dump, but I did have it here. So let's see, dump 2, 3, 4, 5. We can just see here what we're at a very random address. So let's use this one. I saw this following dump. So following dump. This didn't give us the current values of it, did it? So, oh right, it follows this. I want this one. So how do I set what to show here? I want to set this. So we can copy address. Well, let's do that, but I want to show this memory. In another format. Following dump. Yeah, following dump. So now we can see all the letters and everything here, and we can easily see the pattern here that 0, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, and so on. We can check that there are no nulls. So obviously this is like something is off. We didn't get the error we're supposed to get. And also this now shows this. What if I click here? Can I see, like, I want to... Is this just a log? Is this the last line of the log? No. Where can I see this? So this is like what happened, right? We can still see that the APS is 4.2. And so I'm thinking of just changing this. But let's just read and see what their purpose is and see if there's any reason why we're doing this and if we can learn anything more. Because I thought this was useless. So that was better, just seeing it in the dump. We can see all the lines. Much better. This is still a manual comparison. To seeing it like this, we can do 3, 1, 3, 2, 3. This is much better. I just hopped there because I didn't. Did I miss showing it first? Anyway, so we didn't get this. We got the same data twice. This indicates that 0x00 truncated the remaining input. Oh, this is crazy. Yeah. So this was like just a post. One that I was going to finish. So I'm so sorry that I have to stop already. And I'm almost thinking I'll skip training and keep streaming, but I'll have to continue tomorrow. And tomorrow I'll start my time at 13. And I don't have training to run to. So, sorry for the very odd short stream where I was mostly not here, right? Better stop it before I'm mostly not here for half an hour more.